in the guide at number 1, it is asking about fifth roots. So what we're going to do is we're going to write x to the fifth equals 0, x to the fifth equals negative 1, x to the fifth equals 32. And then we need to think of perfect fifths. So this is asking the question, what to the fifth power is 0? So x equals 0. This is asking x to the what power is a negative 1. Well, negative 1 to the fifth power is negative 1. So in this problem, x equals negative 1. Now remember, if this is odd and this is negative, you have one answer and it's negative. Okay, x to the fifth equals positive. This should be 32. Well, if you looked at your perfect fifth list, x would equal 2. Since this is odd and this is positive, there's one answer and your answer is positive. Okay, now we have squares. X squared equals 0.01. X squared equals negative 1. And the last one, x squared equals 36 over 121. Okay, what squared equals 0.01? 0.1. This is even. This is positive. If that happens, even and positive, you always make sure you put plus and minus as your answer. There's two answers. Okay, this one is even and negative. If it's even and negative, you can right away say there are no real solutions. Okay, next one is even and positive. Even and positive means there will be two answers. So we write x equals, well, what squared gives you 36? 6. What squared gives you 121? Or 121 is 11. Because there are two answers, because it's even and positive, you write plus and minus. Look at part C. Explain why a negative real number b has no nth roots if n is even. That's because nothing squared or to the fourth or to the sixth power can ever be negative. And let's say nothing real, because you did learn about imaginary numbers. But let's say nothing real to these powers, so on and so forth, 8, 10, 12, can ever be negative. Let's move on to problem 2. What is the real number root? This one is asking what is the cube root of negative 8. Okay, you're going to go to your perfect, since it's asking about cubes, you're going to go to your perfect cubes. Here are your perfect cubes. The answer will be 2, because 2 cubed is 8. So what's the perfect? Well, let's say this is odd, and it's negative, so our answer is negative 2. Let's look at this one. This says the square root. You should know that the square root has an hidden index of 2, okay? Because it's like squared. So we know that this is even and it's positive. If it is even and if it is positive, we will write a positive 0.2. Now notice on this one does not say, let me show you the big difference here between what we were looking at. Okay? This one wants, what's outside of this root? A positive sign, right? So they just want the positive answer. It would be much different if the problem asked you, what could x be? Okay? These are two very different problems. This one's asking you for the square root of just, hey, what's the positive square root? This one's asking you, what are the two things that x could be? These two problems are very different. On this one, you would write x equals plus or minus 0.2. Okay? But on this one, since this is just the positive square root, you just write positive 0.2. Move on to part C. Okay, so we have an even root. Please write even. We have a negative inside. Even and negative is no real answer. Part D. Part D is a little tricky because inside they want us to square it first. You always work on the inside if they want you to do something. So let's redo this. What's negative 2, the quantity squared? A positive 4, right? So now we're going to take a look at this positive 4. So there is a hidden 2 here. So you ask yourself, well, this is even and it's positive. So that's good, that's allowed, even and positive. They're asking for the positive root of 4. The positive root of 4 is a 2. Again, that would be much different if it said x squared equals 4. If it says x squared equals 4, you would say x equals plus and minus 2. Over here, they're just looking for the positive root. Let's try this again. Look at our index. We have a 3. That's odd, and the inside is negative. If it's odd and negative, it has an answer. The answer will be negative. What's the cube root of 27? Well, you would flip to the back of your paper and you would see that the cube root of 27 is 3. Because this was odd and negative, your answer is negative. Part B. Look how this time it's even. The index is 4 and inside is negative. If this happens right away, you're going to say there's no real solution. Move down to part C. Notice part C needs you to square inside first. So negative 7 squared is 49. Remember how I told you there's a hidden index of 2 here. So it's even and it's positive. Even and positive is allowed. All they want is the positive root. So your answer is simply 7. Part D. There's a hidden index of 2. Since there's a hidden index of 2, you're going to say it's even and the inside is negative. Well, since it's even and negative, you right away say no real solution. What is the simpler form of each radical expression? Okay, on this one, we have to be careful with the fact that we have an x squared in there. They're asking you for the square root. Remember, there's a hidden index of 2. What is the square root of 16? I know you know the square root of 16 is 4. But the question is, do you know what the square root of x to the 8th is? Think to yourself, what makes x to the 8th if you multiply it by itself? Hopefully you came up with the answer that the square root of that is x to the 4th and x to the 4th. Think about that for a moment. If it was x to the 4th and x to the 4th, that would make your x to the 8th. So your answer is 4x to the 4th. Try this in part B. Really all you're doing is you're dividing your exponent by the index. Write that down, dividing your exponent by the index. Alright, in part B, it's asking you what the cube root of a to the 6 is. Well, all you do is you do 6 divided by 3, and you get a 2, right? So your answer here is a squared, because 6 divided by 3 is 2. Now let's do B. B to the 9th divided by 3. What's 9 divided by 3? 3, right? So your answer is B to the 3rd. Now if you're wondering why that works the way it works, it's because if you had 3 of these, okay, if you had 1, 2, 3 of them all together, you would do a squared, a squared, a squared makes a to the 6th, b cubed, b cubed, b cubed makes b to the 9th. Okay? So this is your answer, the cube root. Let's look at part C. Let's divide your exponents. X to the 8th, and then you have an index of 4. X to the 8th divided by 4 is x squared. Y to the 12th divided by 4 is y cubed. It's that simple. You divide your exponents. Let's go to got it 3. Remember in here there's a hidden 2. You have an index of 2. Let's deal with the number first. What's the square root of 81? 9. Now let's deal with the x. X to the 4th divided by 2 is x squared. Let's go to part B. No numbers to worry about, so we'll just do a to the 12th divided by 3 is a to the 4th. B to the 15th divided by 3 is b to the 5th. Let's keep moving. X to the 12th divided by 4 is x cubed. Y to the 16th divided by 4 is y to the 4th. So all you have to remember is that you do 12 divided by 3 to get the 4, like I'm on part B here explaining, and then you do 15 divided by 3 to get the 5 that I got. Okay? The 4 was for the A, the 5 was for the B. Moving on to the next page, we have a word problem. It says some teachers adjust test scores when a test is difficult. One teacher's formula for adjusting scores is A equals 10 times the square root of R, where A is the adjusted score and R is the raw score. If the raw scores on the test range from a 36 to a 90, what is the range of the adjusted scores? Well, let's go ahead and talk about, first of all, when the raw score is a 36. Now that's like what the student scored. Alright, so we'll do one for 36, then we'll do one for 90, and these are the raw scores. Let's do 36 first to find out what the student's new score would be. So you do A equals 10 times the square root of R, in this case 36. So we'll do A equals 10 times, you know the square root of 36 is 6. So A, the adjusted score, is a 60. Let's do R equals 90. A equals 10 times the square root of 90. A equals, let's put that in your calculator. Figure out what the square root of 90 is. It's not going to be perfect. It's going to be a decimal. When I figure mine out, okay, I'm going to do the square root of 90. Get it working. Okay, the square root of 90 is approximately, this is going to be 10 times 9.487. So the student's new adjusted score is approximately, let's give those approximate signs here, a 95. Okay, so the adjusted scores range between, let's go ahead and write it out, between a 60 to a 95. And these are the adjusted scores. And you will find some college teachers who do that. I don't. Let's try this one more time. In problem 4, what are the adjusted scores if you have between 0 and 100? That means if somebody scored a 0 and somebody scored 100. So you do adjusted equals 10 times the square root of 0, and then you'll do adjusted equals 10 times the square root of 100. Well, 10 times the square root of 0 is a 0. Next, 10 times the square root of 100, you know the square root of 100 is 10. That's adjusted equals 100. So in this case, the adjusted scores are actually the same range. They'll go from a 0 to 100, just like they did in the raw.